Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our water flood playlist. And again, we are gonna talk about step right test. Okay, as in my previous video about step right test, this test is very important to be conducted in water flood, especially in water flood in tight reservoir. Okay, and you conduct this test either in a specialized test manner or using, daily well test. So it's a routine test. Okay. So you can conduct specialized tests, but you can also conduct daily well tests to get or to perform this step rat test. Okay. So you perform this test basically to get the fracture pressure or fracture initiation pressure and fracture extension pressure, and of course the fracture gradient, which is very important for your water flood analysis. Okay. And in my previous video, the picture that I used to describe the step rat test is the left figure here. Okay. So you can see I take this picture from this, I think, very useful and quite simple paper, Comprehensive Evaluation of Water Flooding Performance with Induced Fractures in Tight Reservoir, a field case. Okay, and you can see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 dots that describes the, the wellhead pressure, wellhead injection pressure against the injection rate. So we have only few dots here, and you can get this type of result and analysis if you conduct a specialized test. Okay, so you make a test which is quite specific. You want to know the fracture pressure or fracture initiation, fracture extension pressure. You conduct step rat tests. You vary the injection rate, and then you conduct the injection and you measure the wellhead pressure for each injection rate. That's why you have 12 dots here. And then you make a regression. You make lines here. You get the slope, the first line and second slope, okay? And then the intersection between them, okay, here, let's say here at this position, you conclude that as fracture initiation pressure. Okay, so you can get this type of result, which is quite simple, quite clean, very easy to analyze if you conduct specialized tests. But most of the time, yeah, you can say most of the time, we want to get this type of analysis. We want to know the fracture initiation pressure using only simple tests, which is the routine test, the daily well test. However, if you expect to know the fracture initiation pressure, or if you expect to conduct step rat test using daily well test, most of the time what you will get is what we have on the right figure. And you can see you cannot count how many dots we have there. And you can see the clouds, the dots of wellhead injection pressure against the water injection rate. Okay, so using specialized tests, you can vary easily the injection rate. Okay, and then you measure the wellhead pressure, but you cannot do that in daily well tests. In daily well test, it's a continuous operation. Okay, and you get the data each day, each week, each month, and most of those data are are important. You want to keep them, and if you keep all of them and you plot them, this is what you will have. What I want to say is it will be quite challenging, and it will be much more subjective if you want to take a line using this cloud of data. Okay, if you want to conclude a slope, it will be much more difficult compared to the left figure. Okay, and the author of this paper is very good, this one, conclude that we can create two lines with different slopes. The first one is this positive slope, okay, you can see that the wellhead injection pressure keeps increasing when you increase the injection rate, which is reasonable, okay? But somewhere at after this point, if you keep increasing water injection rate, somehow you can see the wellhead injection pressure either being constant or in this case, sort of decreases like that. That's why the author make a negative slope and create a line there. And they conclude that the intersection between these two lines, you can take that as the fracture initiation pressure, okay? And from that, they say safe injection pressure is 5,500, corresponding rate is 3 to 5. Okay, so what I want to say again is step retest is very important. Knowing the fracture pressure and fracture gradient is very important for your water flood analysis. But you can conduct either specialized tests, and by that you can get a clean, result like this, which is very good. But it will be much easier. It will be much practical, and you can get the result much quicker if you take your daily well test data and then you perform analysis like this. Okay, yeah, you can say it will be subjective, right? It's very subjective how you make a line out of this cloud of data, but it's practical. And in engineering world, many times we want to get a quick result and practical technique, which can be obtained if we conduct the right technique. Okay, so to conclude, if you really want to get a very clear and then accurate fracture initiation pressure, then you can go ahead, conduct a specialized step right test where you will vary the injection rate and then you measure the wellhead injection pressure and you can get only few dots from which you can generate positive slope line and negative slope line like this, and then you take fracture initiation pressure. But you can also get rough estimate of fracture initiation pressure by using daily well test data that you have daily. So you can take this and then you generate your analysis and use that as rough estimation, as quick result, quick review. And then if you really want to get the accurate result, you can later on conduct the specialized step right test. Okay, so I think that's practical thing to do. So again, in this video, we learn about step right test. Thank you so much for watching and see you again in the next water flood videos. Thank you.